So in this section, we're covering actually a section from the Algebra 2 honors book because there's something that's fairly important that was skipped in Algebra 2 honors in the spring for the distance learning. I mean, it's not, a huge thing. It's just a type of exponent that you've never learned about. So let's review for a minute the kind of exponents that you do know. So of course, 5 squared means 2 5s multiplied together. 5 times 5, 25. And then you should have learned about negative exponents, which mean fractions. If you're ever curious about why a negative exponent means a fraction, or 5 to the 0s, and the other special exponent, 5 to the 0, why anything to the 0 is 1. If you're ever curious about that, it's because of this pattern here that we have to have. So we know as the exponent increases, it should follow this pattern of multiplying in an extra 5. Well, if we want to continue that pattern, if we want to be able to multiply by 5, multiply by 5, multiply by 5, this is what we have to have. Or if you wanted to start here and then kind of construct what to the 0 power, something to the 0 power is, or something to the negative 1 power is, if you go the other direction, you're dividing by 5. Divide by 5, divide by 5, divide by 5. And so then that shows us what something to the 0 or something to the negative 1 has to be. Okay, so those are the kind of exponents that you do know already, but you've probably never dealt with fractional exponents. So I call them rational. Rational in math means fractions. And so it's fairly important to know what a fraction exponent is. I mean, imagine if you'd never learned a negative exponent. It wouldn't be the hugest thing that would show up all the time, but it would show up fairly frequently, and you'd be kind of at a loss. So we got to make sure we know what fraction exponents are. And it turns out they're actually roots. So let me show you why. So let's say that we approach it from the other direction. Let's say that we've got a root and we know it should be some sort of exponent. Let's try to figure out what exponent would be the same thing as a square root. All right, well, the way we're going to figure it out is we're going to square both sides, because we know that square root and squared will cancel each other out. And so then I'll have 5 right here. All right. Well, then over here, we know the rule is power to a power we multiply. And so x times 2, well, that's the same thing as 2x. All right, well, over here we've got 5 to the 2x, and over here 5, that's the same thing as 5 to the first power. Raising to an exponent of 1 doesn't change something. Well, if the bases are the same, remember the thing that has the exponent on it is called the base, okay? So if the bases are the same, then the exponents have to be the same. So that means that the 1 has to be 2x, so that means x has to be 1/2. So there we go. If the exponent is a fraction, we get a root. 5 to the 1/2 is the same thing as the square root of 5. Okay. What about a cube root? Let's see what a cube root would be. We'll use the same trick, except here instead of squaring both sides, let's cube both sides. And then raising the power of the 3 and cube rooting, cubing and cube rooting will cancel each other out just like before. So we'll have 5. Power to a power, you multiply the exponents. X times 3, that's 3x. Again, if we don't see an exponent, we can always say the exponent is 1. So that means 1 has to equal 3x. That means x equals 1/3. Okay? So again, we get a fraction exponent being the same thing as a root. Okay? This means that 5 to the 1/3 is the same thing as the cube root of 5. Okay? So the denominator of the exponent there is the type of root that we have. So here, what we saw was that 5 to the 1/2 is the square root of 5. Right? So for a square root, it's kind of like there's an imaginary 2 that we don't see. That's the kind of root that it is. Every other number root, we write the number in there. For the square root, we don't actually write the 2. Okay. Now, what about if we had both a root and a normal power at the same time? Let's see what kind of exponent that would be. Okay. Well, let's just write that as x to the 11th, and then we know what a 7th root should be. If a square root was a 1/2 exponent, if a cube root was a 1/3 exponent, then a 7th root, that would be a 1/7 exponent. Well, again, we can do power to a power. We can say this 11, the same thing as 11 over 1. So we've got 11 over 1 times 1 over 7. And so multiply straight across for fractions, we get x to the 11 sevenths. So notice what happens here. We have the power goes in the numerator on top of the fraction, because a normal power to the 11th is 11 over 1, so that 11 is really on the top of a fraction. And then we just saw that the roots are fraction exponents, and so whatever the root is should be in the denominator of the exponent there. Okay, so that's going to bring us to this rule in general right here. Okay, and notice what I'm saying right here is that it doesn't matter whether the power is on the inside and the root's on the outside, or the root's in the inside and the power is on the outside. Either way, you get that the root is the bottom, the denominator of the fraction, and then the power is the top, the numerator of the fraction exponent. If you're not sure about this statement here, that it doesn't matter which order they're in, we could just take a look at what we had here. So what about here if we had x to the 1/7 to the 11th power? That would be the same thing, right? 1/7 times 11 is the same thing as 11 times 1/7. And so this is the same thing as the 7th root of x to the 11th power there. It doesn't matter whether the root is inside or outside, the power is inside or outside, they're exactly the same thing. Okay. So yeah, this is going to be important for you to know here. Just like negative exponents being fractions is just kind of a basic thing that you should know. You should know that fraction exponents are roots. That the bottom, the denominator, is the kind of root, and the top, the numerator, is the power. Okay. So then let's say we wanted to find these without a calculator. So we look at this. Well, we know that it's going to be a fourth root, and it's going to be to the 5th power. We do have the choice, though, of which order we want to write it. So what if I wrote it this way? What if I said the fourth root, and then I put the 5th power on the inside there? Well, think about how you feel about doing 16th to the 5th power first, and then fourth rooting it without a calculator. Probably not too excited about that, right? I like to do a lot of mental math myself. Some people call me a human calculator sometimes, but 16 to the 5th power, no way, not without a calculator. That's not happening. So when we do these kind of things where we want to find these without a calculator, it's typically helpful to do the root first and then the power. So let's make this the fourth root of 16, and then after that, then we'll do it to the 5th power. If you want, you can even put parentheses there. Okay, because the fourth root of 16, that's not too bad. What could we multiply by itself 4 times to get 16? Well, that's going to be 2. 2 times 2 times 2 times 2, that's 16. So what I get is 2 to the 5th power. All right, and then for figuring some of these things out, it can be helpful to actually kind of count on your fingers, count on your hand. 2, 4, 8, 16, 32. Count with your fingers so you don't lose track of how many 2s you've done. But 2 to the 5th will be 32. Okay. Another way that you could look at this here, you could also look at it as well. 16 is 2 to the 4th power, and then if you're raising that to 5 to the 4th, power to a power, we multiply. Those 4s are going to cancel out. We get 2 to the 5th, and so we get 32 again. All right. Another way, let's say you're not familiar with the fact that 2 to the 4th is 16, and so you're kind of getting stuck, not really sure what to do. Well, you could use the fact that 4 squared is 16. What if you looked at this as 4 squared to the 5/4 power? And then power to a power, multiply those exponents. And so you get 4 to the 5 halves. Okay. And so then we change that around. We've got a fractional exponent, so it's going to be a root and a power. We want to do the root first and then the power. All right. Well, square root of 4, notice right now I've just written it like this without the number in there. You can write the 2 if you want, but normally we don't. right? Normally square roots, we don't, there's like an invisible 2 in there. Square root of 5, it's like there's a 2 that we don't normally write. So when the denominator of the exponent, when the bottom of the exponent is a 2, if you want to write the 2, it's not a huge deal, but typically we wouldn't. Typically we would just say square root of 4 to the 5th power, right? Which of course again is 2 to the 5th power, which is 32. So no matter how you slice it, you get the same answer. Math works. Okay. So now let's say we want to look at this one. The first thing we want to notice is we've got a negative exponent. Right? Negative exponent, of course, makes fractions. So because of that negative, I'm going to have a 1 over here. Okay? So this is 1 over 25 to the 3 halves. If you wanted to skip that step and go right to this next step, you could. Okay, so the top is the power, so I'm going to have something cubed, and then I'm going to have some sort of root of 25. If you want to write the 2 in there, you can, but normally we wouldn't. Normally we would just say square root of 25, but that bottom denominator is telling you what kind of root it is. It's a second root. It's a square root. Okay? So of course the square root of 25 is 5. So 1 over 5 cubed. If you need to do that multiplication with pen and paper, pencil and paper, you can. But it's 25 times 5. 4 25s is 100. And you got an extra 25. So it's 125. 1 over 125. Okay. What about a decimal exponent? Well, of course, decimals and fractions are same thing. We can convert them, right? So that's 9 to the 5 halves, 2.5, 5 halves. Okay? And so what I've got here, I've got something to the 5th power. And again, that 2 denominator here, let's start just calling that a square root. If you need to write the 2, you can, but normally we wouldn't. We'll just say that's square root of 9 to the 5th power. And so we've got 3 to the 5th power. Again, if you need to write some of that multiplication down, you can. Maybe count on your hands so you don't lose track of your 3's. So 1 3 is 3, 2 3 is 9, 3 27, 4 81, and then one more 81 times 3, 243. Okay. So then what if we have some variables here? What if we want to go the other way? What if we want to go from the radicals, from the roots, to the exponent? Okay. So you could start here looking at that cube root right there, is going to be, oops, I forgot the 5 in there. It's going to be a 1/3 exponent. All right. And then we've got the 1 over. So we know that this has to be x, y to the 5th to the negative 1/3. Okay. And then because this is just multiplication, that means this exponent does just go on each one there. So we're going to have x to the negative 1/3, and then you're going to have y to the 5th to the negative 1/3. Okay, so make sure you keep straight. If you had addition, you couldn't do this, right? Or subtraction. Like if you had x plus or minus y squared, that would not be the same thing as x squared plus or minus y squared. But if you have multiplication or division, it would work. Then you can put the exponent on both of those there. Xy squared, xy times xy is the same thing as x squared, y squared. It's often true that the pluses and minuses kind of get in the way of things in math. Plus and minuses, when we're canceling fractions, they kind of get in the way. With exponents, they get in the way. So just be careful of that. So now that we got this, we're good to go with x. And then again, power to a power we multiply. 5 over 1 times negative 1/3. We get y to the negative 5/3. Okay. Now this one here, it could be helpful to you to look at this as the 5th root of x cubed times 1 over the square root of y to the 7th, like that. Okay, so what was on the numerator here, this fifth root of x cubed, that's not a negative exponent. That's a regular exponent. And remember, roots were fraction exponents, so the denominator of the fraction is the kind of root. And then 2 to the third power, 3 would be 3 over 1, so the power is on the top of the exponent. And then over here, this one, so the denominator, the bottom of the fraction, is the thing with the 1 over there. That's where we do need a negative exponent. Okay. Now be careful with the empty root there. So remember, with the root, we do need the fraction exponent. And remember, the denominator at the bottom is the kind of root here. Well, this is a square root. A square root, that means we need a 2 there. A lot of people are going to, if they're going too fast, they're going to call this 1/7. 1/7 would have been a seventh root. Okay, the 7 needs to go in the numerator. Power on top, kind of root on bottom. If you need to, you can write that little imaginary 2 in there to help remind yourself square root of 2 is a second root. Square root is a second root. Okay, and so there's our answer. So why don't you real quick, should just take you a minute. Why don't you try these next two problems here? Just make sure that you've got this down, converting between the fractional exponents and the roots, or the root and the fraction exponent. Give that a try real quick here. Okay, so your answers should have looked like that there. So we had a fifth root here. The 1 doesn't really do anything. If you wanted to, you could have written it as x to the first at first. The negative makes it 1 over, and then the 1 is a power, but to the power of 1, we don't typically write that. And again, just be careful with those square roots where we don't have that 2 in there that we see at first. We didn't see a number inside the root. That means it's a square root. We need a 2 down there. Okay. All right. So let's try a couple more problems at the end here. So first, we'll go ahead and rewrite this as an exponent. So we'll say 5 to the 5 over 6, power on top, root on bottom. Okay. And then dividing, we'll write that as a fraction. And then here, if this one is 5 to a power, it would be helpful if we could write that as 5 to a power. And in fact, we can, right? 25 is the same thing as 5 squared. And so this here is 5 squared cube root, so it's 5 to the 2/3. It's the cube root of 5 squared. Okay. All right. Well, with these fractions, be careful here. Some people are going to cancel the 5s if they're going too quickly. You can't cancel the 5s. Okay. Think about if you had something similar, simpler but similar. If you had x to the 5th over x squared, you wouldn't just cancel the x's, right? Hopefully that seems awful to you. Remember what you do with those exponents? You subtract them. That would be x cubed. If you can picture that written out, x 5 times, x there, 2 of the pairs of x's cancel out. You got x times x times x left up there. If you do ever forget your exponent rules, a handy little trick is you can think about PEMDAS. PEMDAS is actually supposed to be written this way. I don't know if you knew. Multiplication and division are at the same level. It doesn't matter which one you do first, just do left to right. Neither one has priority over the other. It's just left to right. Same thing with addition, subtraction. And so if you picture this for exponent rules, you can just go one step down. So what we just saw was when we're dividing, we subtract the exponents. Well, there's also the rule that when you're multiplying, you add the exponents. And then when you have an exponent on an exponent, power to a power, like we did maybe back here, this 5, that negative 1/3, we multiplied those exponents, right? An exponent on an exponent, you multiply those. So one step below exponents, we multiply. Yeah, just a handy little trick for remembering exponent rules. But all that to say, right here, what we need to do is subtract these exponents. So we need 5, and then it's going to be 5/6 minus 2/3. Okay, so again, the base stays the same. Those 5 stay the same, and then we just subtract the exponents. Okay, well, of course, subtracting fractions, we need common denominators. So we'll make that 4/6. And so we've got 5 to the 1/6. That could be fine as an answer. or you could write that as the 6th root of 5. Either one, whichever one you prefer. Okay. Let's do one more here. So a couple different ways that you could solve this one. So one way is we want to think about what exponent we could use to cancel out this exponent. So I'm going to put a number here that I want to cancel that out. Well, if I have an exponent here, remember exponent on an exponent, we multiply. So I need something that I can multiply 3/2 by to cancel out 3/2. And of course, that's 2/3. Well, whatever I do to one side, I have to do to the other. So those exponents cancel out. So I've just got x minus 1 here. And then I've got 8 to the 2/3 there. So I want the cube root of 8 squared. Again, the bottom's the root, the top is the power. So x minus 1 equals cube root of 8. That's 2, because 2 times 2 times 2, 2 cubed would be 8. So then I've got 2 squared. So x minus 1 is 4. X equals 5. All right. So that's one way to do it, probably the quickest way. Another way to do it, if these weird exponents are kind of throwing you for a loop, you could also write out what this exponent is. Right? This exponent is the square root of x minus 1 cubed. Again, 2 in the denominator of the fraction exponent is a square root. We just don't write the 2 in there. And then this equals 8. And so then you could say, well, I'm going to cancel out the square root by squaring. And so then you would have x minus 1 cubed is 64. And then you need to cancel out the cubed. Well, you cancel out the cubed by cube rooting. By the way, with a cube root, with an odd root, you don't need to put plus or minus here. It's if we're square rooting or if we 4th rooted or 6th rooted, any even roots, we would need plus or minus, since even powers are always positive regardless of positive or negative. Okay, so we get x minus 1, cube root of 64 is 4. 4 times 4 times 4 is 64. 16 times 4 is 64. And so we get the same answer because math works. Okay, we just kind of did in 2 steps what we did in 1 here. Raising to a 2/3 power, the 2 is squaring, and then the over 3 is cube rooting. So you can either do it in 1 step or you can do it in 2 steps. Either way, you get the same answer. And if you want to check your answer as well, if you plug that in there, plug in the 5. 5 minus 1 is 4. 4 to the 3/2. So we would square root the 4. Square root of 4 is 2. And then 2 cubed would be 8. So it looks good.